this lecture. Okay, right. So today I would like to discuss the rules for finding derivatives. It's just a summary of the rules for finding derivatives and the derivatives of trigonometric functions. Okay, so let us start. So first one, rules for finding derivatives. And the second one, we will consider the derivatives of trigonometric function. Trigonometric function. Okay. Okay, so that's the outline for today. So first, let us start with the easiest one for rules for finding derivatives. The first one is a constant function rule. And in this case, if the function f is a constant, let's say fx equals to k, where k is a constant, then f prime of x equals to f equals to 0. Yeah. So if f of x is a constant, then its derivative is always 0. Okay. And of course, you may interpret this in terms of, let's say, the gradient of the tangent line. Gradient of the tangent line to the curve itself is just the curve, and the curve is horizontal. So that's why the gradient is 0. So the interpretation will be its derivative is 0. Okay. Okay. So that's the first rule. Of course, you may verify this by considering the definition of the derivative using the limit. Then you will have this one equals to 0. Okay. So let us continue. So another case is about the identity function rule. Identity function rule. And in this case, we will have, let's say, if f of x equals to x, then we have f prime of x equals to 1. Okay. This can be verified by the definition of the derivative using the limit, or if we take a look at the interpretation, then the tangent line here of this graph, the graph of the function is the function itself. It's also the line, but now its gradient is 1. Of course, if you put a scalar there, then the gradient is that scalar in front of x. Okay. Okay. And the next one is probably the most important one, is about the power rule. So for the power rule here, if f of x is equals to x to the power n, so if f of x equals to x to the power n, where n is a positive integer, so n equals to 1, 2, 3, and so forth, then f prime of x equals to n x to the power n minus 1. Okay. Okay. So that's the power rule formula. For example, let's say we consider the following example. Let's say f of x equals to x. The previous rule follows from this. Then f prime of x simply just here you see that the power is 1, so 1 x to the power 1 minus 1. So 1 times x to the power 0, x to the power 0 is always 1, so that will be 1. And if f of x equals to x squared, then f prime of x here becomes 2 here, coming from 2 here, x to the power 2 minus 1, so 2x. Similarly, if f of x equals to x cubed, then f prime of x, yeah, we'll write right here, f prime of x equals to 3, and the 3 comes from the power here, is 3, multiplied by x to the power 3 minus 1, so 3x squared. There. May I repeat, for example, if let's say x is if f of x is x to the power n, where n is quite large, for example, x to the power 100, then f prime of x equals to, okay, 100 comes from here, we'll have 100 x to the power 100 minus 1, and that will be 100 x to the power 99 there. Okay, so that's the power rule. And okay, now first we will see the linearity for the derivative. The first one is the constant multiple rule. For the constant multiple rule, here we will have, if k is a constant, and f, oops, and f is differentiable, okay, meaning f is having derivative, then the derivative of k times f, so k times f prime of x equals to k multiplied by f prime of x. Okay, in other words, you can pull a constant or a number outside the derivative sign. Okay. Okay. So that's the constant multiple rule, and then another important rule is the sum rule. Okay, it's the sum rule here, and for the sum rule here, if f and g are differentiable, then the derivative of f plus g evaluated at x becomes derivative of f at x plus the derivative of g at x. Okay, so f plus g prime of x equals to f prime of x plus g prime of x. In other words, the derivative of the sum is the sum of its derivative. Okay, of course you may combine the constant multiple rule, okay, but with the sum rule here. Let's say take k equals to -1, then you may obtain as a corollary, then f minus g prime of x equals to f prime of x minus g prime of x. And of course, another corollary is that if you have two constants, let's say k1 and k2, then the linear combination, namely k1f plus k2f at k2g, sorry, prime of x, okay, prime at x, simply just k1 f prime of x plus k2 g prime of x. Okay, so that's the linear combination of the derivative of the linear combination, which is a linear combination of derivative. Okay. Okay, of course. Okay, but be careful if we consider the derivative of the product of the function, then it's not the derivative, it's not the product of its derivative. More precisely, we have the following product rule. Okay, product rule here, if f and g are differentiable, then the derivative of the product of f and g equals to f of x, g prime of x plus g of x, f prime of x here. Okay, that's the product rule. Okay, and I will warn you once again that the derivative of f and times g is not equal to the derivative of f multiplied the derivative of g. Okay. Okay, that's the product rule. And the next one is the quotient rule. Quotient rule is about the ratio or about the division of two function. So the quotient rule let f and g be differentiable function. And of course, we restrict to the case where g is non-zero. Let g be differentiable with g of x non-zero. Then the derivative of f over g prime of x becomes f prime of x gx minus g prime minus f of x g prime of x divided by gx square there. Okay, gx square. Okay. Okay, so that's the rule for finding derivative, and of course you need to learn this especially from the tutorial problem with the concrete problem, just finding how to apply these rules for finding derivative. Okay, up to this point, any question or comment so far? Is there any question or comment? Roman Satrio, any question? Roman? Muhammad Rizka Arya, any question? Muhammad Rizka Arya, sorry.
No, sir.
Okay, is it clear? Muhammad Rizka?
Yes.
Okay, good. Okay, if there is no question, then I will continue to the derivatives of trigonometric functions. So we'll continue to the derivatives for derivatives of trigonometric function. Trigonometric function. Okay, so for finding the derivative of trigonometric function, the idea is that we should find the derivative of first sine function and cosine function. Okay, so in this case, now let us consider first f of x equals to, first let us consider sine of x. Okay, and to do that, we need to consider the definition of the derivative, namely by the limit. So f prime of x becomes the limit of h tends to 0 of sine of x plus h minus sine of x divided by h. Simply just the definition of the derivative here. Okay. Okay. So to do that here, first we have to expand this term using the trigonometric identity for the sum of two angle here, x and h here. And here we'll have sine of, for non-zero h, we have sine of x plus h is sine x cosine of h plus sine x cosine of h plus cosine of x sine of h there. Okay, just use this identity. So in this case, we will have put, so here I will replace the box here by the following quantity. So we'll have f prime of x equals to limit h tends to 0 of, just write it here, sine x cosine of h plus cosine of x sine h minus sine of x, okay, divided by h. Okay, so to solve this, so let us take a look at the following term, the last term here. We'll have the same sine of x here and also here. Okay, so I will combine these two. Okay, I will combine, let's say, this term and this term. Okay, we'll combine these two, and then I will have, okay, so I will continue. So f prime of x equals to limit h tends to 0 of, we'll combine these two terms to have sine x cosine of h minus sine of x over h. That's the first term. And then the second term, I will have sine cosine of x sine cosine of x sine h over h. Okay. Okay. And then I should simplify the first term. Okay. So you'll see that we have the vector sine of x. Okay. Can pull sine of x outside. So I will have this one, limit h tends to 0 of sine of x multiplied by altogether multiplied by cosine of h minus 1 over h. And the second term will be cosine of x multiplied by sine h over h. And we recall that limit h tends to 0 of sine of h over h is 1. Okay, so this term, the limit of this term as h tends to 0 is 1. And then the limit of this term as h tends to 0, as h tends to 0 is 0. So and then you'll see that here the limit is taken over h tends to 0. Okay, so there's this is nothing to do with x here. So x can be treated as a constant, as any number. Sine x and cosine of x can be treated as any number. So I can pull sine x outside the limit, and more precisely, I also take minus 1 outside. I can take minus 1 outside this one, outside this. So I will have, by the linearity of the limit, I will have minus sine x, okay, multiplied by limit h tends to 0 of 1 minus cosine of h, okay, this term. And then I can pull cosine of x outside the limit. Limit h tends to 0 of sine h over h. The first limit is 0 and the second limit is 1. Okay, so in the end I will have minus sine of x multiplied by 0 plus cosine of x multiplied by 1. Okay, so after calculating this, of course, I will have cosine of x. Okay, okay, so to summarize here, this calculation, we have the following. If f of x equals to sine of x, then f prime of x equals to cosine of x. Okay, prime of x equals to cosine of x. Okay, and the next one, okay, of course I can write it in any notation. So for example, using the Leibniz notation, ddx of sine of x equals to cosine of x. Okay, or using the differential operator, d of x sine of x equals to sorry, cosine of x. Okay, simply like this. Okay. Of course, as a special case, we may calculate, for example, if f of x equals to sine of x, then we may calculate the derivative at any particular point. For example, calculate the derivative at pi. F prime of pi will be, okay, so if fx equals to sine of x, then f prime of x equals to cosine of x. So f prime of pi will be cosine of pi, and cosine of pi is -1. Okay, as a particular case. Okay, of course you can replace any pi by any number. Okay, because of the function, the cosine function is defined on the real line. Okay. Okay, so that's the calculation here. So let us now continue to the derivative of cosine function. Okay, so let's say start with, let g of x equals to cosine of x. Okay, then we want to find the derivative of g here. Then let us calculate g prime of x. Recall that the definition of the derivative saying that g prime of x is just g, the limit as h tends to 0 of g of x plus h minus g of x divided by h. Then I will have cosine of x plus h minus cosine of x divided by h. Of course, we need to expand this term first. Just if we follow the procedure in the previous calculation, then the first step will be to expand cosine of x plus h. And to do that here, we know that cosine of x plus h is cosine of x multiplied by cosine of h minus sine of x multiplied by sine of h. There. Okay, so if we continue in this way, so the red term here is replaced by this one. Okay, then we'll have g prime of x equals to the limit h tends to 0, limit h tends to 0 of cosine of x cosine of h minus sine of x sine of h minus cosine of x divided by h. Okay, similar as before, we take a look at the common factor here. So here we'll have cosine of x, also cosine of x. So we will group these two into one term. So we will have, okay, I will continue in the next page. We will have g prime of x, or the derivative of cosine of x is limit h tends to 0. Okay, so the first term, I collect the first term with the third term. So I'll have cosine of x cosine of h minus cosine of x subtract by sine x sine h minus sine of x sine of h divided by h. Okay, or I can put it in this way, h, this one is h there. Okay, okay, and then I will obtain the same as before, limit h tends to 0. We'll put minus cosine of x outside, and then multiply it by 1 minus cosine of h divided by h. Okay, so that's the first term. And then the second term minus the limit h tends to 0 of sine of x sine of h over h. And once again, the limit is taken for h tends to 0. So it has nothing to do with x here. Okay, x sine x and minus cosine x here can be treated as the constant here with respect to the limit. So I will have minus cosine of x multiplied by limit h tends to 0 of 1 minus cosine of h divided by h minus sine of x multiplied by limit h tends to 0 of sine of h divided by h. And here I will have minus cosine of x multiplied by 0 minus sine of x multiplied by 1. Okay. So in this case, I will have minus sine of x. Okay. So to summarize this, we'll have if g of x equals to cosine of x, then g prime of x equals to minus sine of x. Okay. 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 So that's the summary here. The same applies if we use the another notations. For example, the Leibniz notation, ddx of cosine of x equals to minus sine of x, or if we use the differential operator notation, d of x of cosine of x equals to minus sine of x. Okay. Similarly as before, the same as before, if let's say g of x equals to cosine of x, then for a particular case of so if g of x equals to cosine of x, for example, I calculate the particular case of let's say g prime at let's say pi over 4, since the derivative of cosine of x is minus sine of x, then the derivative at pi over 4 is just simply minus sine pi over 4. Okay. And in this case, I will have the derivative at pi over 4 is the value of sine at pi over 4 is square root of 2 over 2. So that will be minus square root of 2 over 2. Okay, that will be the result. All right. So, okay. Now let us summarize this. Okay. So, if f of x equals to sine of x and g of x equals to cosine of x, then f prime of x equals to cosine of x and g prime of x equals to minus sine of x. Okay. Okay. So if we use the Leibniz notation, d dx of sine of x equals to cosine of x, and the derivative of cosine of x equals to minus sine of x. Okay, so in this case, okay, this is the summary. Be careful, of course, if the derivative of sine of x is easy as cosine of x, but the common mistake here, sometimes the students write the derivative of cosine of x is just sine of x, forgetting the minus sign. Okay, be careful. Do not forget the minus sign there. Okay, it's very important to have the minus sign there. Okay. Okay, so that's the derivative of sine and cosine function. And to calculate the derivative, let's say for a tangent function, cotangent function, secant function, and cosecant function, the idea is that we will apply the quotient rule and simply the derivative of cosine and sine, the derivative of sine and cosine here. Okay, so that's the idea. Okay, so how to do that? So let us first, before I continue, any question or comment so far? Okay, so I will write the reminder here that, okay, the common mistake here, the derivative of cosine of x equals to sine of x. Okay. So it's not equal to sine of x. It's equal to minus sine of x. Okay, so let us continue to the derivative of tangent function, let's say. So let f of x equals to tangent of x. Of course, we should restrict to the case where cosine of x is non-zero. Okay, so because recall that if fx equals to tangent of x, then recall that f of x can be written as sine x over cosine of x, provided that cosine of x is non-zero. Okay, so in this way, okay, so we write it as the quotient or the ratio of two functions where each function is having derivative. So more precisely, the derivative of sine x is cosine of x. The derivative of cosine of x is minus sine of x. Okay. So to simplify this, so let us write g of x equals to sine of x, and let us write h of x is cosine of x. Okay, let us write in this way. Okay, so we use the quotient rule. So by the quotient rule, by the virtue of quotient rule, we have f prime of x. Okay, so I will first write the formula. F prime of x equals to here g over h. So f of x is g over h. So we'll have g prime of x, h of x, minus h prime of x, gx, divided by h of x squared. Okay, so in this case, we just simply substitute the value of g prime, h prime mg, and h x squared there. So of course, f prime of x equals to, okay, so what is g prime of x here? Roman Satrio? Roman?
Yes, sir.
Okay, what is g prime of x in this case?
Sorry.
What
Pardon.
is g prime of x, Roman? Gx
G
is
prime.
sine x, so what is g prime of x, Roman?
Cos.
Cosine of x, okay, good. So I will put cosine of x there. And then h of x is cosine of x. H of x is cosine of x. Okay, good. Whole thing here is h of x is cosine of x. So we'll write as a cosine of x squared minus h prime of x gx. Okay, then Bimo Ramadan, Bimo Ramadan. If h of x is cosine of x, what is h prime of x, Bimo? Anyar Yasid, Anya?
Yes, sir.
Okay, if h of x equals to cosine of x, here,
H of x, it's
what
minus
is,
sign.
oh, minus sine of x. Okay, good. Minus sine of x, and gx is sine of x. So, sine of x. Okay, and this equals to, okay, okay, Hafiz Adi Wiguno. Hafiz,
Yes, sir.
can you simplify the numerator there? And the numerator will be cosine of x squared. What is the numerator? Of
Yeah,
course, cosine. Yes,
uh,
Hafiz.
what is it? I forgot.
Cosine of x
Sine.
square,
Yes.
and then
Plus
plus
sine x squared.
square, and then what is the result, Hafiz?
1 over
1 over
cos x
1 over
squared.
cosine of x squared. Okay, or we can write it as 1 over cosine of x squared. Okay, where's the 1 over cosine of x squared? And we know that 1 over cosine of x is secant of x. So I'll have secant of x squared, or sometimes you can write it as secant of x squared. So here the writing here is secant of x to the power 2, just to simplify. Not it's of course it's undefined if we consider secant square only. This writing means secant of x and then take the square of it. Okay. Okay, similarly, if you consider, let's say f of x equals to cotangent of x, then we want to find what is its derivative here. So what is the first step here? What is the first step to find the derivative of cotangent of x? Okay. Niklaus Christian Cahya. Niklaus?
Yes, sir.
Yes, what is the first step? If I have now my function is cotangent of x, and then I want to find its derivative, then what is the first step?
The first step is to define the cotangent x
Yes, cotangent of x is written
to cos x per sine
over
x
sine x. Good.
over sine x.
Okay, so first write it as cosine of x divided by sine of x, and then the next step will be applying the quotient rule. And our function here is cosine of x, and then the second function is sine of x. Trivially, we have sine of x square here, and then what is the formula? Derivative of cosine of x, I will use the abbreviation like this, multiply by sine of x minus cosine of x multiply by sine of x, the derivative of sine of x. Okay. 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 So write it here, sine square of x. Okay, what is the derivative of cosine of x here? Atalah Naufal? Atalah Naufal? What is
It's
the derivative of
sine
cosine?
of x.
Oh, negative sine of x. Good. So negative sine of x multiplied by sine of x minus cosine of x. What is the derivative of sine x? Atalah? Atalah Naufal?
Cosine x.
The derivative of sine x is
Cosine x.
cosine x. Good. Okay. Derivative of cosine of x. Okay. Benedict Jeremy, can you simplify the numerator? Benedict? Benedict? Muhammad Rizki? Oh, Benedict, yes. Can you simplify the numerator here?
Let's see.
Benedict, yes.
I think I can use the
Yes, of course, trigonometric
trigonometry.
identity. Yes. And
But
what
I
is
don't
the
remember.
simplification there? Okay, I will have minus sine square of x minus cosine square of x, and that will be equals to Benedict.
Let's see.
I have or I can write it as minus of sine square of x plus cosine square of x. So what is sine square of x plus cosine square of x, Benedict?
Cos 2x, I think.
Sine square of x plus cosine square of x is?
Oh, that's minus. Oh, it's 1.
It's 1. Okay, good. So I will have minus 1 over sine square of x. Or I will have I know that sine 1 over sine x is cosecant of x. So I will have minus cosecant of x squared. Okay, good. Okay. Okay, if so to summarize, if f of x is cotangent of x, then its derivative f prime of x equals to minus cosecant square of x, cosecant x squared. Okay, that's the derivative. Okay, now let us consider the next function. So let f of x equals to okay. We have calculated up to this point the derivative of sine x, the derivative of cosine of x, the derivative of tangent of x, and the derivative of cotangent of x. Now it's of course we'll consider the derivative, let's say, of secant of x. Okay, the derivative of secant of x. Okay, so the derivative of secant of x here, in this case, we'll consider the same as before. We write f of x equals to 1 over cosine of x. Okay. Then the derivative of f prime of x equals to, okay, here, cosine of x square, and then the derivative of 1, okay, I will use the Leibniz notation, d dx of 1 multiply by cosine of x minus 1 multiply by the derivative of cosine of x. Okay. Okay. And in this case, the derivative of 1 is obviously a constant function, is 0. Then multiply by cosine of x is always 0. Minus 1. And then the derivative of cosine of x is minus sine of x. Okay. Divided by cosine square, cosine x square. And in this case, I will have, we'll write it, of course, the numerator will be minus sine of x. So, sorry, the numerator will be plus sine of x. So sine of x divided by cosine square of x. Of course, I can write it as sine of x divided by cosine of x multiply by 1 over cosine of x. And here we have tangent of x multiplied by secant of x. Okay, so the derivative of secant of x will be tangent of x multiplied by secant of x. Okay. Okay. Okay, the next one, let us consider the derivative of cosecant function. So if f of x equals to 1 over cosecant, 1 f of x equals to cosecant of x, and in other words, we can write cosecant of x be 1 over sine of x. Okay, by using the quotient rule, once again, f prime of x equals to d dx of 1, the numerator, multiplied by sine x minus 1 multiplied by the derivative of sine function. Okay, all of this divided by sine x squared. And of course, the numerator here, the derivative of 1 is 0, 0 plus times sine of x minus 1 multiplied by the derivative of sine x is cosine of x, so divided by sine x square. And the numerator becomes cos minus cosine of x divided by sine square of x, and then minus cosine x divided by sine x multiplied by 1 over sine of x. Here I have minus cotangent of x multiplied by I know that 1 over sine of x is cosecant of x. Okay, so to summarize, the derivative of cosine of x is minus cotangent of x cosecant of x. Okay. Okay. Do not forget the minus sign once again. It's important. Okay. Okay. So now let us summarize all the derivative of important trigonometric function. In this case, let us start with okay, I will summarize it in the following table. F of x is given here. Let's say start with sine x, start with the second is cosine of x, and tangent of x, cotangent of x, secant of x, and cosecant of x. Okay, let's say this one is f of x. Then what is the f prime of x here? Prime of x. What is f prime of x? Okay, okay, just to summarize, of course, you do not need to remember all of this if you forget. So at least you know the derivative of sine and cosine function. Then using the quotient rule to recover the derivative of other trigonometric function for tangent of x, cotangent of x, secant of x, and cosecant of x. Okay, so now just a short test here. Okay, to recall the definition, to recall the derivative of the following trigonometric function. Ahmad Shauki. Ahmad Shauki. Ahmad Shauki. Ahmad Shauki. Yes.
Yeah.
Yeah. What is the derivative of sine x, Ahmad Shauki?
F sine x.
Yes. Oh, yes. F prime of x equals to Ahmad Shauki. If f of x equals to sine x, then what is the derivative? Ahmad Shauki.
Derivative is sine x.
The derivative of sine x is Ahmad Shauki.
The derivative is sine x.
So if f of x equals to sine x, what is the derivative, Ahmad Shauki?
Or cos x.
Cosine of x. Okay, good. Okay, so I think that where is the oh no. Okay, good. Iqbal Hafizan. Iqbal Hafizan. If f of x equals to cosine of x, what is f prime of x, Iqbal?
Yes, sir.
Yes. If f of x equals to cosine of x, what is f prime of x? Iqbal? Iqbal?
Yes, sir.
Yes. If f of x equals to cosine of x, what is f prime of x? Can you answer? Iqbal?
Sine x.
Okay.
Minus
Are you
sine
sure?
x.
Yes?
Minus sine x.
Minus sine x. Good. Yeah, minus sine x. Okay. Aiska Faraina? Fairana? Sorry. Aiska Fairana? Aiska? Aiska? Zevanya? 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 Rumi Robani, Rafsanjani? Rumi Robani, Rafsanjani?
Yes.
Okay. If f of x equals to tangent of x, what is the derivative?
1 by cos squared of x, which is second squared of x.
Okay, good. Very good. Just a secant square of x. Okay. Muhammad Made Zulfikar Arifin.
Yes, sir.
Okay. If f of x equals to cotangent of x, what is the derivative? What is its derivative?
Minus cosecant square of x, sir.
Minus cosecant x squared, right? Cosecant square of x. Okay, good. Okay. Zevanya? Zevanya? Can you hear me? Okay. If this is not the case, Mohres? Mohres? Can you hear me?
Yes, sir.
Okay, good. If f of x equals to secant x, then what is the derivative?
For secant x, sir,
Yes, good.
it is it not tan x?
Oh,
Secant
be
x tan
careful.
x.
Be careful. Okay. Previously, I have calculated this. If, where is the? Okay, this one. Mohres,
Yes.
what is the derivative of secant x? Can you see in the whiteboard?
Wait, it's it's tan x secant x, sir.
Okay, it's tangent of x multiplied by secant of x. Good. Okay. Aiska? Aiska? Yes. Matthew Silalahi?
Yes, sir.
Okay. If f of x equals to cosecant x, then what is the derivative?
The derivative would be minus cotangent x times cosec x.
Okay, good, very good. Okay, so that's the basic for the derivatives of trigonometric function. Of course, okay, so you do not need to remember all of this, but at least you have to know the derivative of sine x is cosine of x, and the derivative of cosine x is minus sine x. Other formula can be derived easily by using the quotient rule, okay, and the definition or the definition of other trigonometric function and the trigonometric identities as well. Okay. Okay. Any question or comments over up to this point? Is it clear? Is it clear?
Yes, sir. Yes, sir.
Okay. Good. If you can follow this, then in the next lecture we will consider the chain rule. Okay, the chain rule and higher order derivatives as well. For example, if you consider the second derivative, the third derivative, and even the n derivative of the function, and that will be the next two topics. Probably the chain rule is quite familiar for you. For example, if you want to calculate the derivative of composite function, then the formula is available, and the second derivative maybe it's familiar if you consider the concept in physics. For example, the first derivative means the velocity, and the second derivative means acceleration in the moving particle. And we'll learn about the second derivative is simply just the derivative of derivative. And The third derivative is just the derivative of second derivative, and so forth. And we'll learn that in the next lecture. And also for the implicit differentiation and related traits, probably it's quite new for you, and differential and approximation as well. So the last three topics about the implicit differentiation, related traits, and the differential and approximation probably are quite new for you. And the next two topics about the chain rule and the higher order derivative is quite familiar for you. So we have to arrange the quite amount of time to learn the topic in the next week. And do not forget to work on the exercise, especially the tutorial problem. Okay, and we'll see. Okay, so in the afternoon I will plan for the tutorial probably from 3 until 4 approximately, because we do not have quiz. And also I have assigned the homework for you, so please work on the homework in LMS. So please do it on time, because it will contribute to your understanding to the subject, and pragmatically it will be calculated for the final grade in the next in this semester. Okay, so that's all for today. We'll see you again in the afternoon. So I
Sir?
will, yes, pardon.
For the homework, is it the limit chapter or is there another one?
Limit one, because
limit
I
one.
have written the assignment there, the problem with the limit, and I already indicate the number there in the
Okay.
tutorial problem. Okay,
Thank you.
I think it's quite clear instruction. Of course, the next homework will be the homework about the derivative. Okay. Okay. So that's all for today. We'll see you again in the afternoon. Thank you for your attention. Thank you for your time. We'll see in the afternoon. Thank you. Have a nice day. Thank you.
Thank you, sir.
Yes, sir.
Thank you, sir.
Sir.
Thank you.
sir.
Thank you very much, sir.
Thank you. You're welcome.